just some extra things to chat about. I will share link also to session on Saturday so that we do a recap of study units 8 and 9. And then, because tonight is the last of the normal study units, next week in this time slot we will just start continuing to recap. So probably start looking at study unit 3, because tonight we will probably do a recap of study unit 2 as well. And then we just continue so that we have enough time for you guys to go through this again before you write exams. I don't know if there's any exam dates has been set yet. So if you have any, please share. But I don't think there has been dates set yet. So okay, so let's start with the last study unit. So we're gonna look at simple linear regression. For simple linear regression, when we get to the examples, I'm also going to show you how to do that in Excel. Again, for some of the linear regression questions that we're gonna ask, you probably need a calculator that can input 2 rows of data, so X's and Y's. But I'll definitely show you rather than in Excel how to do that, so that you don't need to go and buy a scientific calculator or a financial calculator. So when we get to the examples and we look at the how to solve the equation lines, I'll show you in Excel how to do that. Okay, so let's start with a bit of theory, and again, important, some of the theory that you guys need to be aware of. Just if I ask you a theory question, in a set of questions that we're going to work through, I've got actually two theory questions, so we will look at that. What we're going to look at is just a simple linear regression model. So if you need to, you don't really need to learn these formulas. You can just think about it. The formula that we're going to use mostly is y is equal to mx plus c. So that is what we're going to use most of the time. Your b0 is basically your c. Your b1 is the same as n. Okay, so it might be that we see different types of formulas. There might also, in some of the textbooks and other study guides, you might even get something like this, where it is ax, and a is basically now your slope, and b is the same as c. It will be your y cutoff. Okay, so that might also be in some of the textbook where they have a different type of linear line. So basically, things that we need to know on this linear line, B is the y-intercept, so that could have been the C as well that we have in others. B1 is the slope, so that could have been the M as well in my other formula. And then EY is the expected, so sometimes that is the same as the Y in other formulas. This, just take a note of it. Again, don't learn it nearly out of heart and anything like that. We've got you've got this now, so you please don't worry too much. If it is in a type of theory question, you have it now available. So know about it if I want to ask it in a theory question. Then the other thing that is important, and again, it's easier when we get to look at answers when we need to start eliminating. Um, so remember your slope of your regression line is, in this instance, is always positive if it has this line. It is negative if you have the other way around. And then there is actually no slope if it is a straight line. Okay, so if it is a straight line like that, and let's say that went through 4, your straight line would be y is equal to 4, because your slope would have been 0, and 0 times x gives you 0. So the slope, if it is a straight line, will basically fall away, so that your straight line is just the one that then goes through your y-intercept. Okay, but important. So if we have those two, that's always the positive, that's always the negative. So positive slope and negative slope. Again, if you can print these, it's always easier then to have at hand. I might also check how I can add it to some of the other work we've done, so it's easier to have it on one page instead of 3 slides. Okay, so we then get to what we call an estimated simple linear regression. So again, very similar to the previous line. That is our estimated value. The B0 is your y-intercept. B1 is your slope. Again, you don't really need to know what the difference is. Just remember that it is there for you to use. Okay, then I think what we're going to look at is, one important thing is we're going to get a set of data, and it will be always x and y. So how it will look like if it was x and y. So let's just say that is x, that is y. So let's make that 4 and 3, 6 and 7. So if I was looking to plot it, I would go on the y-axis, I look for 4. I will go on the x-axis and look for 4. I look on the y-axis, look for 3, and where those two basically meet, that will be my point 4 and 3. Okay, I'll do the same for 6 and 7. So let's say that was 6. Let's say that was 7. Where the two meet, that will be my point 6 and 7. Okay, so X is always first, Y's are second. Okay, so they will not ask you to do a plot because it's multiple choice, so um, they can't really ask you to do a plot. What they can ask you is to say, well, we've got a linear equation. Which one of the graphs is a linear equation? So when we do later recap of this study unit, I will add something like that in because I know I don't have one at the moment. So I will add something in like that because what they can do, and let me just nearly show it to you, they can do this. They can, let's say that's 1, 2, 3, 4, and they can tell you, okay, my formula is minus 4x plus 3. Okay, and then they can give you, say, a line that goes through there. 3, they can give you a line from there. That's 3, they can say, there's a line through 3. And they could have added, let's say, something that is going there through 3 and there through 1. Okay, so just by then looking at these options, and that's why I wanted to, I'll do a better one for you when we do a recap of this, but we see that that is negative. So a negative slope can be this one or this one. So not 1 or 3 because that's positive slopes. And then we see, okay, well, it also goes through your y-intercept of 3. So here it goes through y-intercept of 3. Here it goes through 1, so that's wrong. So I would have said, okay, the one that looks most likely to be the line is option 2. So that can be a question that they ask, but I will write up something nicer for you guys for later on. Okay, so then the next thing that we can look at is, so we talk in stats about the least square method. Please don't go and study it. If it's also in your, it's not even in your study guide, but it might be in your book. So please don't go and study it. It's not for you to know how to look at it at the least square method. What we need to nearly just take out of it is this formula that we need to be able to calculate the slope, because it might be that they give you some of the information to calculate the slope. So instead of giving you the data set, they might tell you, okay, but they give you that value, they give you that value, and they give you that value, and you need to calculate. what I have done in one of my Excel spreadsheets, this is also part of it. So if you get it, you can just substitute. So the same vein where we have B1, there's a formula to calculate B0 as well. So for B0, how we calculate that is, and again, if you haven't seen this before, the Y with a stripe on top, that is actually a calculation to work out the mean of the values of Y. And then the X with the stripe on top is to work out the mean of the X values. So if we had X values of 4, 3, 5, the mean of that would be the sum of the X's divided by N. So that have been 4, 3, and 5 would have been 12 divided by how many numbers? So the mean would have been 4. So if we wrote it down, the mean would have been 4. So remember way back in study unit, what was it? 3, where we actually calculated the mean, exactly the same. Now we just have 2 points. So we will calculate the mean of the x's, calculate the mean of the y's, and then we can use it in this formula as well. So that you basically then can substitute the b and the y. So let me just, I'm going to take this slide out. So that if you then substitute it in the b and y, the b0 and the b1, you get this formula as well. So I'm just showing you nearly all the methods that you can use. There's another method where, again, when we look at coefficient of determination, we need more data. So again, it might be that they give us in an example, they tell us, well, the SST is this, or the SSR is this, or the SSE is this. So again, depending on what information they give us, they can ask us a few different things. What I've seen during the years is that it doesn't matter what nearly thing they ask you to do, they will always give you the data points. So that you can always use all your Excel or your calculator to calculate what is needed. What they sometimes do, and just be aware of that, obviously to trick you, they sometimes write it, the data set, they might sometimes give you the Y's first and the X's second. So just remember, if they do that you swap it around, because if you're going to read it into a calculator, the Y's first, it will calculate you the wrong answer. The same if you put it in Excel, it will also then swap the things around. But I'll show you in one of the examples um, how that is done so that you just can see the differences. Okay, and basically to calculate the coefficient of determination, so This is one of the ways to use that SSR and the SST. Other way is on your calculators, you will see there's not a coefficient of determination, but for R. So just the normal R, that is um, your relationship one. So it's your correlation coefficient is R. So that is on all your scientific and your financial calculators. We will also be able to use it in Excel. And then if we need to get to the R square, it basically is for R times R. So again, we'll test a few of the differences because you're supposed to come to the same answer. So if we use this method, if we use this method, we are supposed to get the same answer. Okay, so it is basically just which one, again, is the one that you want to use, and the one that you understand the best. Okay, so let's go. So they've done it a bit the other way around to say, oh, you can go from your coefficient of determination to your correlation coefficient by taking the square root of that. So again, either or, which one makes it easier for you to do, but I'll show you a few options. Okay, and then another thing that they can ask nearly as a definition question is they can ask you, but what assumptions do we make about that original, in that original formula we had this error that was always available. Um, so they can ask you in a definition um, what assumptions of the error term is correct, or pick the one that is not correct. So the things that, again, please don't remember it, we have it. So the error is a random variable with mean of 0. So when you take a mean of your error values, it will always be equal to 0. The variance of that error term will be denoted by the variance sign. The values of E are independent, so they don't influence one another. And then the error E is normally distributed. So basically, you can nearly see if a mean is 0, and we go back to study unit 7, when we looked at normal distributions. Remember, we had a mean of 0 and a standard deviation of 1. Um, it's exactly the same when we look at the error term. So the error term will always be normally distributed, and that is why the mean is also 0, because it is normally distributed around that error term. Okay, so that is a lot of the theory behind it. The next few slides is just to give you a summary of that theory, with, again, the summary of the formulas that we might need to use. Again, some theory around the R coefficient that lies between -1 and +1, and then the last one also give you a bit of nearly perspective of things that they can ask you in a kind of theory question again. So they talk about a weak linear relationship, a strong linear relationship, perfect relationship, and then if it is a positive or negative relationship. So again, just go through it when I send it to you guys, but anything below 0.5 is a weak relationship. Anything above 0.5 is a strong relationship. If it is exactly 1 or -1, it's a perfect relationship. So a perfect relationship will be that your dots is actually on that straight line. That will be a perfect relationship. I don't want to say never, but you seldom get a perfect relationship. So the chances that you will ever see something like that in any questions or industry is very slim. So what they can put together is to say if I've got a value of between 0.3 and 0.5, we can say it's a positive weak relationship. If it was a minus 0.3, we could say it is a negative weak relationship. So they can, okay, let's just get this back. So they can nearly group that 3 to 5 and 5 to 1 with a positive or negative. So if I had a positive 0.7, it is a positive strong relationship. If I had a negative 0.6, a negative strong relationship. So they can, in a question, nearly add those two together to instead of just asking a weak relationship, they can add the positive or the negative to it as well. Okay, so let's look at a few. So let's first look at the theory questions, and then we can go into the questions that we're gonna use Excel for. Okay, so here they ask us, we only need to look at the correlation coefficient R, and they ask us if all the points in a scattered diagram lie on the regression line, then the correlation coefficient R must be 1, must be -1, must be either 1 or -1, must be 0, or we need more information. Okay, so just by quickly in the chat, which one would you have said is the right answer? Okay, cool. We've got one of our answers is 3. Any other takers for this one? Okay, so 3 is correct. Okay, so as we said in the previous slide nearly, so when it is on that line, it is a perfect correlation, so it will be 1. But remember, there's also a line that has a slope. If that is perfect, that's negative, so that relationship will be -1. So that is why it is either 1 or -1. because they didn't tell us in which way the line goes. If they said, if all the points in a scatter diagram lie on the positive regression line, then it would have been 1. If I said it lie on the negative regression line, then it will be -1. But if they don't tell us that it is negative or positive, then we assume it will be both. Okay, so that is on the coefficient correlation. Okay, the next one, they also ask, so they give us a bit of information, and then they ask us some questions around it. So they tell us, consider a data set containing number of pages n equal to 15, and we calculate the coefficient or the correlation coefficient as 0,474. Okay, 474. And then they tell us the numbers of pages and price are directly related. Would you guys say yes or no? Number of pages and price are directly related. So they give us the number of pages or pages and price for 14 or 15 books. Okay, so number of pages and price are directly related. Yes, it is. It's not strong, but there is still a relationship. So remember, strong relationship more than 0.5, a weak relationship smaller than 0.5, no relationship is 0. So there is definitely directly related, but not strong, but it is definitely related. Okay, a scatter diagram of a data will show an upward slope. Yes or no?
Yes.
Cool. Okay, because that is positive, the slope will also be positive. The more pages a book has, the higher the price. Interesting one. Yes or no?
Yes.
Perfect. So because it's a positive slope, more pages, the higher the price. And it could have been, price could have been here as well, and pages could have been there. Doesn't matter at this one, because it tells us the higher the price, the higher the pages, or the higher the pages, the higher the price. So perfect. Because it's a positive slope, that is the assumption that we can make. The coefficient of determination will lie between -1 and 1. And we're now referring to R square. Does that lie between -1 and 1? Okay, so this is where the trick comes now in, and this is where they want to catch you out. Okay, so if we had r equal to minus 0.3, and we r squared it, it would have been minus 0.3 times minus 0.3, which makes it positive. Okay, so your r square will always be positive. So it's actually from 0 to plus 1. Okay, so a bit of a tricky question. Um, your coefficient of your correlation coefficient lies between minus 1 and plus 1. So that correlation coefficient lies between minus 1 and plus 1, but your r square, or your coefficient of determination, will always be between 0 and 1. Okay, so that is just the catch in here, because as we assume now, and I think that is where one easily makes the mistake, is you think, but r can be negative, so why can't r square be negative? But the simple reason is the minus times a minus makes it a positive. So your r square will always be between 0 and plus 1. Okay, so that one is the incorrect one. And then the last option, if there is absolutely no relationship between the number of pages and price, R will be equal to 0. And that was also what we set up top. No relationship, it will be equal to 0. So if there's no relationship and it's equal to 0, your coefficient of determination will also be equal to 0. So that is the only time where r square will be equal to 0, is when your coefficient or correlation coefficient is also equal to 0. Okay, so that's a bit on the theory side. And again, I think what is really important, and I will look for more of these as well, for when we do some revision work on this, because what I've seen in the past is there's always one question in the exam on theory for this study unit, and about one question on um, on an example that you need to work out. So I will see if I can nearly get out of the previous papers most of the theory questions as well, that we can just go through all of them, because I know I've seen somewhere that they also talk about, where was it, the independent and dependent variables. So I don't know if we mentioned it somewhere in here. If not, I will just make sure. Yeah, so the xi and the yi, so they talk about it very, very quickly in your study guide as well. I think there's maybe one comment on it, but it can be that they are something like this as a definition as well. And yes, I've seen one of them, so I will definitely add that to the pack that we will go through. Okay, so let's look at a few problems that we will use Excel for. So in this one, basically they give us a data set of X and Y, and then they ask us which equation of the regression line will will be the best. Okay, and you can see in these options, this one, these two look very similar in a sense. So there's a 38 or 35.8 as a slope and there's as a cutoff, and the other way around for where the other ones are very different. So probably between 1 and 2 is the correct answer. Okay, but let's quickly take this one. I'm going to put it in Excel, and I just want to put in the numbers here. Then I'll make it bigger. Okay, so there already I make a mistake. So it's 23 and 96. Then it is 46 and 113. 16, 128, 54, 98, 28 and 89, and then 33 and 12.5. Okay, and then you can see they also, if we make that a bit bigger, they tell us it's sample of 6 months, so we can see it's 1, 2, 3, 4, 5, 6. Okay, so let's just make that bigger so that you can see. So there was our 6 numbers. I just want us to only see the, sorry, I just want to quickly, okay, so that is, again, let's just crop that. Okay, cool. So here is the lines that we need to look at. Okay, so in Excel, again, there's nice formulas. So there's a slope formula, and now also important to see. So they ask us in Excel, what is your known y's? So they ask the y's first and then the x's. Okay, so for the slope, we got for 1.32. So for 1.32 will be the slope. But just check if we set the x's first, and then the y second, we would have gotten a different number. Okay, so luckily none of the others are the answer, but then we would have gotten a different answer. So very important that we get the slope right. So again, when we look at the formula, just be careful. They want the y's first, and then they want the x's. And then for the y cutoff, let's just quickly see. There's supposed to be intercept. Okay, so there's the formula for intercept. Again, the y's first, and then your x's. And there you can see then the y-intercept is 35, and if we needed to round it off to one decimal, 35.8, and there we have our slope of 1.32. Okay, so I will also share this along with you, that you can use it. But I'll also share the bigger one with you next week when we start doing the revision work as well. So easy, if you now get a data set of 6 numbers, you can put it in. If you get a bigger data set, just so you normally won't get more than 10. Let's see if we can, in any case, increase it for you guys to 10. So next time that you do it, you can go up until 10 without any issues. Okay, so with this one, we just read in the data in Excel. We used the formulas that is built into Excel to get it. You can use your financial or your scientific calculators. There it also gives you a X and Y, and to B0 that you can work out. So that will also be a way of calculating it. Okay. Are you guys happy with this one? Would you rather use Excel, or would you use your calculator? But again, which one is easiest for you to do? Okay, in this instance, they did not give us any of the formulas, so there was no ways that we could have worked this out or worked that out, or there was the other one, so worked this one out or that one out with the data, unless we now actually try to work this out, but that is going to take you ages. Yes, we can do it. So we can build that formula for you into Excel. On my other spreadsheet I have, so I will show you next time with the built-in functions as well how to do that. Okay. So this one, please use the calculator or use Excel, and then option 1 is your correct one. Then here is now one. So again, they give you the data, but they also give you some extra information. So what I did was to say, okay, it might be that you need to use one of these formulas, or that one, or that one. There might be other formulas that you can also use. They could have included more formulas for you, but again, I'll show you quickly how to do it in Excel, and then it might be that we take one of the other formulas and do it for, let's say, B1 or B0. But again, if we did use it in Excel, what I would have done, so let's just put it into another spreadsheet. And let's just make it a bit bigger again. And let's just look at the data points. So again, we'll use X and Y. It was 4, 12, 6, 16, 8, 25, 9, 50, 12, 59. Okay, so that was your 2, 3, 4, 5 points. Okay, so if we wanted to work out the mean, there isn't a mean function in Excel, but there's an average function. So that would have been the mean of X. That would have been the mean of Y. So if we want to use that later on in one of these formulas, we will be able to do so. But let's work out the slope, and then let's work out the intercept, and then we take it from there if we need to look at some of the other options. Okay, so again, slope, the x's, or sorry, the y's first, then the x's. So the slope is 3.5.3, 3.543. Okay, so the intercept is that? No. And we're looking for the correct one. So intercept, no. Okay, so both of those two are wrong. So let's just, so the slope was 3,543. Slope 3,54. That is at least correct. Let's look at the intercept. Again, intercept y is first, x is second. So intercept, and let's round it also off to, we'll see now. So minus 3.24. Okay, minus 3.1. 3.21. Okay, so that's a bit. Let's just check my numbers again if it was right. 4, 6, 8, 9, 12, 12, 16, 25, 30. Okay, so close to that. So if you probably used these numbers on top, you would have gotten to exactly the same. But that is the right answer. Let's just look at when the coefficient of correlation is 0.99, the coefficient of determination is 0.9950. Okay, so let's work out that. Okay, did you get the answers that I got, or the answers that's in here? Did you get the Excel answers or the ones that's in the slide? Okay, cool. Okay, so then here was an error on this, and it should be minus 3.24. Okay, cool. So then at least we know our number of minus 3.24 is correct. Okay, so the other one was, let's see if we can get the R. So that was coefficient of correlation. So there is a correl. So here, what is interesting, it doesn't matter which is which. So you would see that your correlation is 0.99. And then if we need to work out the R to the power of 2, which is your determination. So they ask us if 0.99 times 0.99. So you will see that is 0.98 and not 0.995. So that is also wrong. And then the last one is, so they say when x is equal to 10, then the estimated y is equal to 35.4. So if we put in 10 there, because that was the one that we saw is right, but let's work it out. So let's say that is y hat that we're working out. So that would be equal to the slope, sorry, equal to the intercept plus the slope times whatever x there would be. So they told us the x was 10. So if we had, let me just, I want to make it sure that we get the order right. So if we added in a x of 10, our answer would have been 32.2. They told us the answer is 35.4, so that one is also wrong. So what they did in this one is they just multiplied the x by that and forgot to minus the bit of the intercept. Okay, so instead of taking that still away, they only added the 10 in. Okay, so that then would have been the one also that is incorrect. Okay, so your correct answer would have been that straight line. Okay, so what we could have done, and let's quickly look at this formula to work out B1. So let me just crop this a bit. Okay, that didn't crop it, it just made it smaller. I'm gonna just add it on a new one. Okay, and let's just add this formula onto that Excel as well. Okay, so if we now had to work this out, we could say, okay, but let's use the information. We know that, and maybe we do something like this. Now n is 5. what other information do we need? That sum of xy is 1082. Then the sum of x, so we're going to do this so that you guys again know what we're talking about. Sum of x, the sum of y. So the sum of x was 39. The sum of y was 122. What else do we need? We've got the n. We need that one. So the sum of x times x is 341. And the sum of y times y is 3446. Okay, so then we can say, okay, let's try to work that out. That's also slope. But now I would use a few formulas. So n times that sum of xy minus the sum of x times the sum of y. Just put that all above the line. Then divide by below the line. Again, n times 3, where always sum of that. Okay, so that is nearly one sum. And now to just make sure that we're doing it right, the sum of x to the power of 2. Oof, okay. And now we need to hold thumbs that that is correct. What is it? 3,54. 3,54. Okay, so exactly the same. If we've replaced it in the formula, then to get the intercept, we can say, okay, we've calculated there. So let me just copy that over. So the intercept is the average of y minus your slope. So let's just move it into. Okay, and then we get the minus 3.24 as well. Okay, so there's the minus 3.24 as well. So obvious that was written wrong. So they probably changed something, and but actually now we've proved it with the other functions as well. If you look at this with the formulas, that the slope and the intercept was exactly the same. So again, I will share this on the WhatsApp group as well, that you have it, so that you can also, when these problems come up in your assignment, you have a Excel to use as well. Okay, so that is on assignment or study unit 11. Um, that we basically have worked through study unit 11 now. So I'm gonna stop the recording, but then in a few minutes time, we can